First, construct the terminal arm for the angle at 4 pi over 3, then identify the coordinates of its POI with the unit circle by realizing the related acute angle is pi over 3, and that a special triangle can be constructed by drawing a vertical line to the x-axis. Coordinates of the POI are -1 over 2 and -√3 over 2. Cos of 4 pi over 3 will be the x-coordinate of the POI on the unit circle. Therefore, cos of pi over 3 is -1 over 2. Again, first construct the terminal arm for the angle at pi over 6, then identify the coordinates of its POI with the unit circle by realizing the related acute angle is pi over 6, and that a special triangle can be constructed by drawing a vertical line to the x-axis. The coordinates of the POI are √3 over 2 and 1 over 2. The cosecant of pi over 6 will be the reciprocal of sine of pi over 6, which is the y-coordinate of the POI on the unit circle. The y-coordinate of this point is 1 over 2, and its reciprocal is 2 over 1. Therefore, a cosecant of pi over 6 is 2. And finally, same thing, construct the terminal arm for the angle at 7 pi over 4. Then identify the coordinates of its POI with the unit circle by realizing the related acute angle is pi over 4, and that a special triangle can be constructed by drawing a vertical line to the x-axis. The coordinates of the POI are 1 over √2 and -1 over √2. Cotangent of 7 pi over 4 will be the x-coordinate of the POI divided by the y-coordinate of the POI. This results in a value of -1 for cotangent of 7 pi over 4. For 1b, so to find the POIs, set the primary trig ratios equal to the reciprocal trig ratios. Then I isolated for the value of the trig ratio. This results a value of 1 or -1 at the point of intersection. Therefore, the y-coordinate of the point of intersection of primary trig ratios and their corresponding reciprocal is always 1 or -1, regardless of the trig ratio. This is because a number must equal to its reciprocal, and the only two numbers that equal to the reciprocals are 1 and -1. And now for question 2a. First, I use the given max and min values to find the amplitude and the midline. I also know that the period is 25 minutes for a full rotation. Therefore, the k value is 2 pi over 25. And since the rider starts at the minimum point, I can use the negative cosine function to write the equation. I also use the given information to construct the graph. The height of the rider is at 50 feet at times 0 and 25 minutes, and 540 feet at 12.5, which is halfway through the rotation. This allowed me to quickly set up a graph. To see where the rider is at in terms of their height, I plugged in the value of time, that is 20 minutes, in the equation of the height function, which I got in part 1. For the height of the rider at 20 minutes, I found that there will be at 219.19 feet. And finally, to determine the interval of time at which the rider is at or above 400 feet of height, I set the function equal to 400 and isolated for t to find the first time that the rider reaches a height of 400. This happens at approximately 8.01 minutes to the end of the ride. As well, therefore, the second time rider will be at 400 feet will be 25 minus 8.01, which is equal to 16.99 minutes. The rider will be at or above 400 feet between these times. Therefore, the interval of time they were looking for is from 8.01 minutes to 16.99 minutes. And here's my graph, and that's all my answers. Thank you.